See, in this case, in this topic, limitations of Ohm's law, it is representing that everywhere this V is directly proportional to current, it will not work. See, V is directly proportional to current means if voltage is increasing, current should increase linearly. But this will not happen every time. It will not happen in the case of thermistor. It will not happen in the case of diode. It will not will happen in the case of triode. It will not be happen in the case of semiconductor. So if this is not following, that means Ohm's law is not obeyed. So the device which is not following Ohm's law are known as non-ohmic device. See the first case, see here. It should be linear, but it should be linear. It should go in a straight line. But see, it is taking a deviation. It is why? Because voltage and current are not directly proportional. Okay, see, even in the case of our diode, if we are increasing the voltage, if I'm increasing the voltage, current should increase. Current should increase linearly, but current is not increasing linearly. It is following a certain path. Why it is happening, we will study in this chapter semiconductor. If we are reducing the voltage, current is decreasing, and current is not decreasing linearly. Okay, current is not decreasing linearly. Same for the third case. Check the third case. In the material like gallium arsenide, the semiconductor material, in that too, initially it will follow Ohm's law, but then there will be no linear region, and then there will be a negative resistance region. That means what? These three things are not following Ohm's law. The device which is not following the Ohm's law are known as what? They are known as non-ohmic device. Okay, now